Okay, boys and girls, for today's Wednesday's lesson, we're going to continue with similar figures. There's two main things that I want to go over today. We have been on the Monday and Tuesday lesson, you've been seeing how to find the missing side by pairing the corresponding sides and setting up a proportion. Okay, now there's a little shortcut that works in some cases. Okay, I want you to look at these two triangles. They are similar. All right, they're similar. One's smaller, one's big, same shape, different size. Now I want you to match the corresponding sides. 6 corresponds with 12. They're in the same position. 8 corresponds with 16. And 10 corresponds with 20. Now, here we have all of the sides. There's no missing side. But I want us to see a relationship. How did it go from the small one to the bigger one? Well, if you compare 6 with 12, 6 to the 12, there's a relationship of times 2. Okay? From 10 to 20, it's times 2. From 8 to 16, it's times 2. Okay? Now, this relationship, when it's being multiplied by the same number from the small one to the big one, this number, the 2, is called your scale factor. Okay, so the scale factor is it's a relationship when you multiply or divide all sides by the same number. Okay, and it's kind of like a shortcut. It might work with some, it might not work with others, because then you're going to have decimals. So when you're able to see it automatically, a relationship, that you can use your scale factor without having to do a proportion. And I'll show you in a little bit some more examples. Now, when you go from the small to the big one, well, you have to multiply. Okay. But if you're going from the big one to the small one, if you're going from big to small, well, how do you make a big number smaller? And it's going to be division. Now, it's only multiplying or dividing. There's no adding, no subtracting, because think about it. When you have a proportion, the two operations are multiplication and division. Okay, so when we're going from big to small, we're going to divide, and you can see it here. From 16 to 8, if we're going backwards from the big one to the small one, we divide by 2. The scale factor is still 2. So let's do some examples with the scale factor and then with a proportion, so that you can see that we get the same answer, and the scale factor might be like a shortcut, like I said. So let's do it here on this one. We're on page 4 in your packet. 12 pairs up with 3. Remember that we want to match from left to right. Okay. And then you have 20 with X. So 20 with the X. Okay, so now, if we were to set up a proportion like we were doing Tuesday and Monday, 12 pairs up with 3 and 20 pairs up with X. Okay, that's the way we were doing it, setting up the proportion with your corresponding sides, your pairs. You cross, multiply, divide. 20 times 3 gives you 60. 60 divided by 12 gives you 5. So X, the missing side, is 5. Okay? Now, if we do it with the scale factor, there's a relationship from the big one to the small one. We need to divide. So let's check. From the 12 to the 3, is it divisible by a whole number? 12 divided by 4 gives me 3. So I'm going to do the same to this one. 20 divided by 4 gives me 5, which is the same answer that I got with my proportion. So again, the scale factor is a little shortcut that you can use. Remember that from small to big, you multiply. And from big to the small one, you're going to divide. Okay, let's try with this one that's flipped. And remember that on the Tuesday video with the flipped similar figures, you can redraw them or you can see them automatically. They're in opposite positions. So 28 pairs with 6 and x pairs with 5. So remember that we're going to do it with the proportion and then I'll go ahead and do it with the shortcut. So 48 pairs with 6. Remember that we're going from left to right. And then x pairs with 5. X pairs with 5. You can go ahead and cross multiply 48 times 5. 48 times 5. 240. 240 divided by 6 gives you 40. So the missing side for the big one is 40. Now, is there a relationship from 48 to 6? They're dividing by 8. But now we're going from the 5 to the x. So it's like if we're going backwards from the 6 to the 48, you do it times 8. So 5 times 8, you get 40. So just remember that if you're going from big to small, you got to divide. Like that's what we did over here. But now I wanted to go from the small one and get the bigger one. So I have to multiply. So 8 times 6 gave me 48. So 5 times 8 gave me 40, which is the same answer. Now, the scale factor will work for some of you. Some of you might feel more comfortable with the proportions. It will be your option, guys. The proportion will always, always work. The scale factor works in some cases. It works all the time, but some of them get complicated with decimals. So again, the matching of the corresponding sides will always just be set up your proportion, cross, multiply, divide. Okay. Moving on, how to check if they're similar when they give you the two sides, like all of the sides, and you want to check if they're similar. Well, what you can do is match your corresponding sides, 8 with 4 and 3 with 2. Okay, 8 with 4, 3 with 2. So you can go vice versa. I know I said left to right, but here I have all of the sides. So I can go from the big one to the small one. I'm dividing by 2. So does it work the same for 3 or 2? 3 divided by 2, does it give me 2? No, 3 divided by 2 is 1.5. So these ones are not similar. These ones are not similar because they're not being divided by the same number. Okay, let's try the next one there. Okay, or let me go back to this one. The video cut off, guys, so I was doing my notes and it just stopped recording. But another way to check if they're similar or not is you do your proportion, but you have all of the sides. 8 with 4, 3 with 2. You cross multiply. 8 times 2 is 16. 4 times 3 is 12. They're not equal. They have to be the same number when you cross multiply them. So they're not the same number. They're not similar. Okay. Now I want you to look over here at the bottom one. On this one, I had to redraw. This one was lying down. This one was standing up. So I redrew it, and when I redrew it, the 3 is no longer here, but it's now standing up, and the 1.5 is here at the top. Now look at the relationship. From 3 to 6, it's times 2. From 1.5 to 3, it's times 2. So when they're multiplied by the same number, that means they're similar. If I do the proportion, 3 pairs with 6, 1.5 pairs with 3. You cross multiply. 3 times 3 gives you 9. And 1.5 0.5 times 6 gives you 9. So I got the same number here at the top when I do my proportion and check their cross multiplications. They're equal, that means that they're similar. Right? If you get the same number when you do the cross multiplications, okay, that means that they are similar. Okay, over here I have another example. Look at the relationship from 3 to 6, it's times 2. But 6 times 2 does not give you 9. It gives you 12. So that's why they're not similar. If I do my proportion, I pair up 6 with 9, 3 with 6. Check the cross multiplications. 6 times 6 is 36. 9 times 3 is 27. They're not equal. They're not the same number, so they're not similar. And this one at the bottom, it's a square and it's a rectangle because they have equal sides. If this is 4, 4, 4, 4, and over here you have a different shape of rectangle, automatically not similar. Go ahead and go back and rewind the video to go over the scale factor. Again, the scale factor will work when you can see it right away. If you're trying to figure out, okay, well, what number times 6 gives me 9? If you don't know it, then just do the proportion, guys. Okay? The proportion, it's just matching your sides like we did on the Tuesday video and the Monday video. And you feel free to go back to those videos as well.